back to another session of From the Field, brought to you from all the way from Auckland, New Zealand. My name's Trevor Kennedy. I'm a Principal Solution Architect for AWS New Zealand. Today, I want to talk to you about Amazon Fraud Detector. As part of my role, I look after AI and ML services in New Zealand. So I help our customers be successful with AI ML services. I'm going to dive a wee bit deeper into those services in a second. But one of the more popular services that I get asked about a lot is Amazon Fraud Detector, which means that we've done a lot of work with this. Before I came back to New Zealand, I came back a couple of years ago after being away for about 20 years based out of the UK. I also worked with our customers over there that were looking at fraud detection as part of an AI ML implementation, artificial intelligence, machine learning implementation. So I want to take some of that knowledge and share that with you today as well. Some gotchas. What do you need to look at if you're going to implement fraud detection within your environment? So that's kind of what we want to cover today. One of the other questions I get as the AI ML guy in New Zealand is, I'm just starting out in artificial intelligence. I'm just starting out in machine learning. How can I learn a wee bit more about it? I have a real strong interest. Obviously, in the last few months, a lot of the generative AI stuff have really taken off. So things like Midjourney, DaVinci, ChatGPT, etc., have become really popular. And all of a sudden, everyone's like, oh, how do I get into AI? So one of the other things that I'll be doing is on my personal Twitch channel, which you can see there is While We, I'll be looking at running a session on AI ML. So how to start in AI ML, and then eventually over a series of Twitch sessions, we'll get stronger and stronger and stronger until we get to the stage where we can call ourselves an AI ML expert. I'll also be able to give you some really good resources that are useful. When I started out my journey in AI ML, probably about 5 years ago now, there wasn't a lot of free resources available out there, but today you've got a bunch of brilliant resources that you can use. Yes, AWS has some great resources, although our AI ML learning have a tendency to focus on AWS, getting AI and ML running on AWS, so artificial intelligence running on AWS. But there are also some great resources out there on just learning about artificial intelligence, learning about machine learning. So I'll share those as part of that series as well. So if you're interested, just pop across to While We on Twitch here, follow me, and then once I go live with those, you'll be able to either follow us live or watch the video on demand. The whole concept of that program is to get you up to speed on artificial intelligence and machine learning, even if you don't have a background in it. Technically, there's some programming in there, I'm afraid. With artificial intelligence and machine learning, there's a bit of Python, so it does help if you know a bit of Python. Otherwise, it can be a bit of a struggle to break into this area. So just a bit of a heads up. You can also follow me on Twitter, so Trevor Kennedy, nice and simple, on Twitter as well. And I'll broadcast out when we're going to be doing those Twitch sessions. But today is all about Amazon Fraud Detector. So let's jump into it. I'm going to do a demonstration of it and show you how it works. But before we do that, I just want to talk about the AI ML stack that we have available here at AWS. At the bottom of the tree are our processes. So, you might be an organization that just wants to use our compute power to be able to train your machine learning models. Now, we absolutely provide that compute capacity, right? If, for example, you want to buy an A100, which is the typical hardware used today to be able to train machine learning models, to buy a NVIDIA A100 in New Zealand will cost you between 400,000 and 500,000 New Zealand dollars. So it's a pretty expensive investment. And then paying that up front can be a bit of a struggle. And to be honest, you're probably going to need more for these larger models. The statistics I saw yesterday, in fact, when I was researching this, is originally the GPT model, which was a machine learning model taught on 175 billion parameters, used 8 A100 GPUs. The new model that they're about to build, the GPT-4 and 3.5, if they use those 8 A100 GPUs to train the new model, it would take them 3 years of training on the new model. So that's obviously not very scalable. You can't wait 3 years to train a single model. So being able to use the cloud resources for that compute is a nice, easy way forward. And to give you an example, the A100s in AWS, it costs you like $50 an hour, and you get charged per second. So if you only use it for 2 minutes, you're paying 2 minutes of that hour for that $50. So it becomes a lot easier to be able to scale up your machine learning activities if you're using that cloud infrastructure. So not a massive upfront investment. So if you're just looking for compute, we have that available for you. That's the bare basics that we have for AI ML. At the next level up, we have what we call our ML services. So these are for people that want to build their own machine learning models. Maybe you work for an organization, maybe you're doing a startup, you want to build your own model, you've got really good data, and you want to be able to train a model from scratch. So as part of that, you want to clean up the data. As part of that, you want to be able to train the model. And then as part of that, you also want to be able to put that model into production. So our ML services are the solutions that allow you to do that. So SageMaker Canvas, for example, is a tool where it's no code, low code. So you don't need to learn programming. You can just bring your data. You throw it into Canvas, and what Canvas will do is it'll take your data, it'll automatically clean it up for you. A good example of that is, let's say as part of your data, you have an address like Auckland, New Zealand. Machine learning models can't use strings. So machine learning models would need to convert that address to something that is usable by the machine learning model. The typical method for taking categories or strings is to convert them using, there's a few different techniques we could use in machine learning, but the more common technique that you'd want to use is to convert it into what we call a binary bit array, where you're essentially taking those strings and converting them into zeros and ones, and then the machine learning model can use that. If you don't know how to do that, because maybe you haven't done the machine learning course and you're not familiar with it, well, Canvas does that all for you. So what Canvas will do is it'll take all your data, regardless of what the format it is, and then it will convert it into usable data for the machine learning model. It'll then train the models up, and then it'll give you a model at the end to say, all right, these are all the options I've tried. Here's the best option that gives you the best results for your machine learning model. So Canvas allows you to do that. You don't need any programming experience. All you really need is good data. And what do I mean by good data? Typically with these machine learning models is we want labeled data. What that means is we need to be able to say what you're looking for. So for example, fraud detection, if we're looking for transactional fraud, we need labeled data to say this is fraud, this is legitimate, this is fraud, this is legitimate. So each line of your data, each record of your data needs to be labeled as either fraudulent or legitimate, so that the machine learning model can learn what features of that transaction is an indicator to fraudulent transaction or to a legitimate transaction. So labeled data is important when you're looking at this, when you're looking at creating a machine learning model. If you haven't labeled your data, you'll notice here on the left-hand side, we do have a tool called SageMaker Ground Truth. And Ground Truth allows you to go through and label the data. So a good example is this. Maybe you've got, 100,000 images. And some of those images contain what you're looking for. Maybe, for example, you're looking for defects in a production line. So some of those images have defects in them that, that's the anomaly that you're trying to detect. You would label that image as a defect. Well, using ground truth, we help you label your 100,000 images. So we will go through and say, okay, this one is no defect. This one is no defect. This one has a defect. And over time, the ground truth will learn what a defect looks like. So it'll go through and be able to label all of your data. You can then take that labeled data and use it in a machine learning model yourself. And then finally, the big platform for this at the ML services is SageMaker Studio. As I mentioned, this is the platform that allows you to train, prepare your data, tune your parameters, and then put your model into production. So that's the platform that you would use to actually train a model and get it into production, and then users can start using your model. So that's the ML services. So the typical people that use the ML services are, data scientists that are working for organizations, or people that are creating their own models and want to put it into production. So, a startup possibly might use that as well. And then above that is our AI services. So our AI services are essentially our SaaS offerings for machine learning. So this is where we've already trained the models for you. You can customize them if you like. So you can bring your own data to customize, a number of these models, or you can just use our pre-trained out-of-the-box model ready to go. And this is where fraud detector sits. So it sits in one of these services. Theoretically, you could just bring your data and say, hey, Amazon fraud detector, is this fraudulent or not? And we would be able to tell you that this is fraudulent or not. The challenge with that is you really want to customize it on your own data. So you don't want to, if you're looking for transactional fraud, what you sell on your online shop is going to be different than what I sell on my online shop. So fraudsters, how they target you and what goods they target from your online shop is going to be different than my online shop, right? So traditionally, when you're training up these AI services, you do want to bring a sample of your own data that you can do what we call transfer learning. So you're taking all of our knowledge and experience on what fraud looks like, for example, and then you're transferring that onto your own model with your own customized data. And that's essentially what these AI services allow you to do. You don't have to in some of these instances. So, for example, one of the other services I'll talk about today is Amazon Recognition, which is the ability to process images. And for those, you just bring the image and it will start telling you stuff about those images. So yeah, we'll take a closer look at that. We had a question here, is this with SageMaker? Actually, for the AI services, you do not need to use SageMaker at all. SageMaker is when you're building your own models from scratch, or when you're using off-the-shelf models and you want to customize them. So, for example, GPT. If you wanted to create your own version of GPT, there's a GPT created by OpenAI. They produce the model. You can within SageMaker, you could say use this GPT model and then customize it for yourself, or build your own GPT model if you wanted to from scratch. You probably don't want to do that. I know that the GPT model costs like $5 million of compute. So you probably don't want to create your own one. But what you could do is start with the current GPT version, or alternatives to GPT. The largest alternative to GPT is a model called Bloom. So you could use the Bloom model and say, right, now I want to train it on my data specifically. So you take all the knowledge from GPT, or you take all the knowledge from Bloom, and you train that in SageMaker. With the AI services, you don't need SageMaker. With AI services, they're just off-the-shelf SaaS offerings that you can consume as a user. So no need to dive deep into SageMaker. No need to understand how the SageMaker platform works. You just jump into Fraud Detector and say, hey, Fraud Detector, here's my data. Go and learn on it. And that's what I'm going to show you today. So you'll get to see that in practice. And the other one I'll show you today is recognition, which is looking at images or videos. Again, that's off the shelf. So you can say, okay, I want you to take this video and tell me whether there's any sensitive content in here, for example, like nudity. So then you could decide to hide that, right, on your website if somebody's uploading a photo, for example. Recognition does that out of the box. So again, don't need to retrain recognition. You can, but out of the box, it'll provide that functionality for you. And we'll take a quick look at recognition today as well. Excellent. Okay, so that's what we're going to take a look at. Let's talk about some of the challenges with fraud detection. So I've seen this a number of times within our customer base, both here in New Zealand and in the UK when I was working for Amazon in the UK. First one is you're not spotting the new fraud patterns soon enough. And this is a massive problem that people underestimate. Here's what you need to realize. When people commit fraud against your online business, they're very good at it and they're very adaptable. So if, for example, you started off where you were not recognizing that something was fraudulent, right? So maybe someone comes to your website and you sell electronics. Think of like Amazon.com, right? So we sell electronics, we sell food, we sell household goods. We pretty much sell anything on Amazon.com. When they come to our website, typically what they will do is they will target devices that they can sell really, really easily. So maybe mobile phones is a classic example, right? So they come to our website and they buy 5 iPhones from the website. From our perspective, we would eventually detect that and say, okay, we can see this pattern that they're buying these small electronic goods that are easy to resell, and we detect that and say, okay, this is fraudulent. So anytime in the future when someone tries to buy 5 mobile phones, that would be detected by the fraud model to say, this looks really suspicious. We need to put this through enhanced verification before we actually approve this transaction because this looks like typical fraud. What do the fraudsters do then? They change their behavior, right? So instead of buying 5 mobile phones, what they do now is they buy a single mobile phone, and maybe they buy it with all the accessories, and maybe they buy another electronic good that's easy to sell. Maybe like, there's products called Good Hair Days, or GHD, I think they're called. And that was another customer I worked with in the UK. That was another target for online fraudsters. Because it was easy to sell and expensive. So these, really, really posh curlers, for example, you could sell them for like $200. So again, fraudsters would target that and then go and sell it on eBay or wherever they were going to sell it. So again, they changed their behavior. If you don't spot that change in behavior, which is typically the reason they're changing behavior is because you've detected them, right? You've detected that the fraudulent transaction has occurred. So they change their behavior. If you don't spot that fast enough, what's going to happen there is you're going to end up having a wider window where you're losing revenue to the fraudsters. So being able to detect it quickly is really important. And we'll talk about how we can help with that. The second one is if you don't want to block legitimate customers. So in the retail industry, particularly in the UK, they did a lot of research about what we call customer friction, which is the more hoops that you make your customer jump through, the more likely they will abandon the transaction. So, if you make it nice and easy, one of the very first Amazon innovations that we were known for Amazon.com was the one-click checkout, right? Where you basically add the, whatever you're buying to your to your list. I'm saying this is what this is what I want to purchase, and then when you go and check out, you just do one click and you check out, and the goods get shipped to your the default shipping location. And the reason we did that is because that reduced customer friction. It made it easy for the customer to transact with us. If you make it difficult for the customer to transact with you, they're more likely to abandon the transaction. They're more likely to abandon their shopping cart midway through the transaction. And of course, you don't want to do that, right? As an online business, you want to make it as easy as possible for the legitimate users to transact with you, while at the same time making it difficult for the fraudsters to transact with you. So a good example where you might make it difficult is for every single customer that purchases from you, you might say, I need to validate who you are. I need you to, maybe prove you are who you are by showing me your ID, or turning on the face cam and I can compare your face against your photo ID. So that'd be an example of where we're making it difficult for the customer to transact with us. Now, in some instances, that could be perfectly legitimate, right? So if it's a high fraud score, we might want to put them through that extra enhanced validation. But if it's a low fraud score, then we just let the customer through to say, okay, you want to buy this? No problem. Go to your shopping cart, check out, done. We'll ship it to you. So we want to reduce that that friction as much as possible. Then the second one, of course, is you don't want to review every single transaction manually before you ship. You can imagine how many billions and billions of transactions that we get with AWS every year. If we had to manually review every single transaction to see if it is fraudulent or not, it's just not scalable, right? And as a large retailer, if you're looking for fraudulent transactions, or even a large website, if you're looking at something like YouTube, or you're looking at something like Reddit or Twitter, having to manually approve every single person that signs up to your website is just not scalable. So again, we want to be able to automate this as much as possible. And of course, that's the whole concept of fraud detector. So those are the key challenges. How do we solve that? Well, we provide you with a fully managed AI service that uses machine learning to detect potential online fraud. With this, as the name suggests, it's fully managed AI service, right? So fully managed means you don't need to worry about the infrastructure. You don't need to worry about scaling up and scaling down. If you only get one transaction a minute, or you get 10,000 transactions a minute, you need to be able to handle those. You don't need to worry about it, right? This is a fully managed service where we worry about the infrastructure. We worry about making sure you've got backups and that you're already always operationally up and running. We do all the hard work for you when it comes to putting this model into production, and that's what fraud detector is. What sort of fraud can we detect? There are 4 types of fraud that you would typically see with most organizations. The first one is new account sign up. So this is your first opportunity to detect whether it is a legitimate user or a fraudulent user. So when someone comes up to your website and they say, yep, my name is Bob, and I want to sign up to your website, we want to take a look at that information and just validate whether or not this looks like a legitimate user. Now, when they sign up, this is a tough one, right? You go, okay, so how do we know whether it's a legitimate user? All they're providing surely is just their username and email address, right? So that can't give us too much information about whether it's a legitimate user or not. Well, actually, there's a few pieces of information that we can use based on Amazon's 2 decades of fraud, right? Obviously, being one of the, a very large retailer, global retailer, we see a lot of fraud, not only on Amazon.com, but also on AWS when people are trying to sign up with fraudulent accounts. So we've got 2 decades of experience understanding what fraud looks like when new users sign up. We take all of that experience and we've built it into this fraud detector model. So things that are useful when we're looking at new account signups. The IP addresses are useful because we know what what good IP addresses look like. So for example, if they're signing up from a home address or a broadband address, that's probably less likely to be fraudulent. If they're signing up from a VPN address, that's more likely to be fraudulent. If they're signing up from an IP address range that belongs to a large cloud provider, so i.e. they're firing up a virtual machine in the cloud, that's more likely to be fraudulent, right? So the IP address can give us some useful information about whether it's fraudulent. What type of browser they're using. Often these new account signups are bot accounts, and they're scripted accounts, right? So they're what they tell us about their browser is useful for us to detect whether or not it is fraudulent. And of course, their email address is another one. So their email address allows us to detect. We know what a good email address looks like, what bad ones look like. So, if it's a name with a whole bunch of random numbers after it at gmail.com or outlook.com or hotmail.com or one of the anonymous providers, that would be more likely to be fraudulent, right? So we can take a look at those key statistics and tell you whether or not we believe it is fraudulent based on what we've seen at Amazon and AWS over the last 20 years. So you get all that knowledge built in. Second one is real-time payments. So this is when people are trying to send payments from one location to another location. We can look at the providers that they're using. We can look at their accounts. We can look at where the money's going to, what country the money's going to, et cetera, et cetera. So again, we have a lot of experience on that. Online checkouts, what they're actually checking out. So what does their cart look like? So what does the mixture of their cart looks like? For example, it's very unusual for people to buy 5 iPhones in one sitting, or 5 iPhones and 5 Samsung devices in one sitting, right? That's a very unusual transaction. So we can look at the makeup of their cart and tell you whether or not we believe that is fraudulent, again, based on Amazon's 2 decades of experience. And then finally, loyalty and promotions. If you're I know people like ChatGPT, people like Midjourney, allowing your first month free. Netflix allowing your first month free. Amazon Prime allowing your first month free. And what we don't want, or what you don't want as a business, is people just to keep on signing up to that first month for free using different email addresses. And again, based on our historical knowledge, we can detect that abuse of those loyalty and promotional programs. So Amazon Fraud Detector, when you build it, it has models for each of these use cases, and you just tell us what model that you're interested in, bring your sample data along, and then we'll train it up on your sample data. So that's what Fraud Detector does. As I mentioned, it's taking all of our experience, right? We've got 20 years of experience doing this stuff. We know what fraud looks like. You can imagine the amount of fraud we would see on a website as big as Amazon.com, the billions of transactions we see every year. You can imagine the amount of fraud we see on AWS.com, Amazon Prime. There's a lot of really, really good data that we use over and over again when we're looking at detecting fraud. So we've taken all that knowledge, we've bundled it into our machine learning model, which you then get to take advantage of by doing using fraud detection to transfer that across to you. And it's easy to get up and running. There's only 5 steps to it. So the first one is we want your historical data, right? We need to customize this specifically for your data. So today I'm going to take a look at transactional fraud. And I'll show you the type of data. What does good data look like compared to bad data? I'll give you an example today. What type of data should you include? So the things you need to think about if you're going to look at rolling out a fraud detection model. But this allows us to customize all of that experience we have to your specific use case. That's why it's important. We typically recommend, so for transactional data, for example, we have some guidance about how much data we want to see. So we typically recommend 10,000 samples so we can do transfer learning. So 10,000 of your samples of transactions. Out of that 10,000, we want around 400 to 500 of those to be fraudulent examples. So again, you do need to label this data, right? So 9,500 of them will be legitimate transactions, and 500 of them, 400 to 500 of them will be fraudulent transactions based on what you've seen in the past. Now, you're going to know it's fraudulent because you would have got chargebacks on your previous transactions. You want to keep that data as fresh as possible. Now, I know that's not always possible in New Zealand where we don't have large transactions. To get 10,000 transactions for us, for the average business in New Zealand might be 6 months, maybe a year's worth of transactions, right? We typically want those transactions to be as fresh as possible. So you probably want it within the last 90 days if you can do that. But we realize that you may have to go back longer than that, particularly in New Zealand, where we might not have the levels of transactions that you might get in a larger country. But keep that data as fresh as possible, because that's going to allow us to see the latest trends in your fraudulent transaction. Next one is select options and training models. So once you've uploaded your data into S3, you're then going to pick which type of model you're going to do. So is this a new sign-up model, or is this a transactional fraud model? I'll show you this as part of the demonstration, but you just tell it which model we're going to be training against, because we do actually have separate machine learning models for each of these different use cases. Once you've done that, then the model will upload the data. It'll validate your data to make sure that it's usable. If it's not usable, it'll give you an indication of what you need to tidy up in that data to make it usable. So, for example, one of the compulsory columns, do you have all of the compulsory columns available in the transaction, so in the data that you've got? I'll show you where you can see what those compulsory columns are as part of the demo. But if they're not in there, it will indicate to you, we can't use this data because you're missing the label column, as an example. And then once you've created the model, what you want to do is you want to create business rules. So the output of this model will be a fraudulent score. So it'll say, we believe that this is a legitimate transaction or a fraudulent transaction based on this score. And the score will be between 0, meaning we don't believe it's fraudulent, to 1,000 to say, yes, this is definitely fraudulent, right? So you'll get a score in between. Probably what you want to do is you want to create business rules based on that score and other parameters. So, for example, you might say if the fraudulent score is above, 900, and the billing address and the shipping address are the same, the billing address and the shipping address are different, then create a business rule to say deny this transaction, right? And the reason you want to do that is because you look at the billing address and you look at the shipping address, and it's different than where it's going to, particularly if it's, so the billing address is in New Zealand and the shipping address is into overseas country, and the fraudulent score is high. You might just want to automatically deny that, right? So you can create a business rule to say, if it meets this criteria, mark it for auto deny. What happens then is when a transaction comes in, it assesses, it'll give you the score, so it'll give you a fraudulent score, so you'll always get that back as a result, but it will also assess the transaction against your business rules, and it will return the results of that business rule as well. So you get two things back from the model. You get the fraudulent score, plus you get the output of this business rule. So fraudulent score was 920, the output of the business rule is deny the transaction. That then goes back to the to your middleware processing, and the answer is to deny the transaction. So therefore, your middleware can say, no, we're not going to do this transaction. Sorry. If maybe it's somewhere in the middle. Let's say the fraudulent score comes out at 500, and in this instance, you say, okay, the fraudulent score is kind of in the middle. We're not sure if it's fraudulent or not. The shipping address and the billing address is the same. So the person who's trying to buy this is shipping it to their current location. In that instance, you might say, okay, we can approve this transaction, right? So even though the fraud score is above 0, so it's in the middle there, you've created a business rule to say this looks legitimate to us based on what we've seen historically. Therefore, create a business rule to say allow this transaction as an example, right? So you get to create these business rules, and like I say, the model will provide the output of that business rule once you send in a new transaction. And then final step here is to deploy the API into production. And then any new transaction from that point forward, you send it to the API and say, hey, API, is this fraudulent? It looks at it. It looks at the full transaction. It does an assessment based on the machine learning model. And then it sends back those two things we talked about. It sends back the fraudulent score, and it sends out the output of that business rule. And then based on the output of the business rule and the fraud score, you can then choose whether or not you're going to process that transaction or whether you're going to reject the transaction. Or maybe the output might be send the user for enhanced verification, right? So ask them to prove they are who they say they are, as an example. Okay, let's take a look at Fraud Detector. See how this all works. So you go into your console. The thing you want to search for here is Fraud Detector. So we go into Fraud Detector. It's going to pop up, and this is where you're going to end up. On the left-hand side is where all of our models are going to end up. What do you need for fraud detection to work? Well, it depends on the model that you're going to create. So if I go into the best area to start here is the data model. So the data model is what data do you need for the different use cases that we've talked about earlier on. So for example, under online transactional fraud, if I select this and I scroll down, it will tell me the types of data that I expect to see for this model to work. In this instance, it's saying there's 51 pieces of data that would be useful for us. Some of that data is mandatory. Looking on the left-hand side here is the mandatory stuff. For me to do transactional fraud, this is what I need to provide to the model. So for example, I need to provide the timestamp of the event. I need to provide an event ID. So that's a unique ID for the transaction. So it'll be like the transaction ID. The entity ID. So this is the user that you've identified. It's like, customer number would be a good example of this. The entity type, whether it's a user or a customer, as an example. The label timestamp. So when we labeled this as being fraudulent or not, if we've labeled it previously. The event label. So is it fraudulent or is it legitimate? So you do have to have that. And then we've got some recommended. So those are the mandatory ones, right? That's the bare minimum. If you provide us with those bare minimums, so that's 1, 2, 3, 4, 5, 6 fields, you can create a transactional fraud model for those 6 fields. If you've got that historic data, you're good to go to create a brand new fraud transaction model. However, we do have some recommendations as well that is good to have. So these recommended ones, if you've got them, they will enhance the prediction capability of your fraud model. So for example, user's IP address, right? So we're going to take a look at the IP address and see whether it's on a VPN as an example. The user agent, what browser type they're using. So this will tell us whether it's a bot or not. So that's a good one to have. User device ID is a good one to have. The channel by which they're coming. So, whether it's a web user or mobile user. Again, what we've seen historically is botted activity is traditionally run on web, not always, but traditionally run on web. And then you've got some optional ones. But again, the more of these you can provide, the more likely we can improve the predictive capability of the fraud model. So there's up to 51 different, you can see there's loads of extra extra information that we're looking for that'll be useful. So there's up to 51 different pieces of data that'll be good for predicting online transactional fraud. Let's take a look at new account sign up. For new account sign up, there are only 17 pieces of information that will be useful here. Again, some of them will be mandatory, things like a timestamp that they occurred, the label, whether previous ones were legitimate or not. And of course, for this one, it is more likely going to be useful to have things like the IP address and user agent, and the email address will be ones that you definitely want to have for signups. As it turns out, for mandatory, we only need 1, 2, 3, 4, 5 pieces of data for this model to be successful. So if you come through here, these are all the different models, all the different fraud activity that we can search. All you need to do is take a look at your data, look at the mandatory stuff, make sure you've got that covered. If you've got that covered, upload it to S3 and you're good to go to create your model. How do you create your models? These are nice and simple to create. You come in and you can say, create a brand new model. So I created a model here. All I did is I uploaded my transactional data. Let's take a closer look at this transactional data because I think this is where what's important is to understand what this data looks like so you can understand whether it's going to be useful or not. So in this instance, I've provided some useful data. I've also provided some data that's not very useful necessarily for predicting outcomes, just because I want you to be able to see what this looks like. So here's first one. So you do have, this is a compulsory one, right? Event label. Is this fraudulent or not? In my case, 0 means not fraudulent and 1 means fraudulent. So these first few ones here are not fraudulent, and line number 8, I've got a 1 there. So that one there is a fraudulent transaction based on historical data. Next one is the timestamp. We know that this was also a compulsory one, and the label, that was also a compulsory one, and the event ID, that was also compulsory. The entity type, that was a compulsory one, and the entity ID, which is the user ID, that was also compulsory, right? So there's my 6 compulsory columns in my data. So if I've got that, that's good enough. I don't need any of this other data. By adding it, I'm going to get better predictions, but I've got the bare minimum 6 ones there. So that's a good start. Next one I've got is the card BIN number. Interestingly, we have found that this is useful for detecting fraudulent transactions, because often certain banks, and so BIN numbers essentially identify the banks, certain banks have higher risk than other banks around the world. So if the BIN number comes from a higher risk bank, that can increase the likelihood of fraud. Customer name. This is unlikely to be useful in predicting the outcome. Who knows? Maybe every Ricky is dodgy. Like you can see here that Ricky had a fraudulent transaction. So if their name starts as Ricky, maybe they are dodgy. But I feel that this is unlikely going to be useful, a useful piece of data. But let's include it and then get the machine learning model to tell us whether that is true or not. Billing street, possibly fraudulent. If we've seen it before, that could be useful. But to be honest, I probably don't. Where this might be useful is if we compare the billing street with the shipping street, right? So that allows us to compare the two, where they match up. That's less likely to be fraudulent, but where they are different, then it's more likely to be fraudulent. And the same would be true for the billing city, billing state, zip code, latitude, longitude. Again, probably not as much as useful, but let's include it just because we've got that data. Customer's job, possibly useful. I'm kind of like on the fence on that one. I'm not convinced that it'll be that useful, but there you go. IP address, absolutely, that's going to be useful. We can do IP insights on that based on Amazon's historical list of bad IP numbers. Customer email addresses, again, this will be really useful, based on what we've seen historically. If they've got really long numbers in their names, that's often an indicator for a fraudulent transaction. Phone numbers, yeah, I mean, where this might be useful is if we can recognize a pattern that they're providing a phone number that's not in the country where the billing address is, or they're providing a phone number that's not in the country where the shipping address is. That could be useful. So I could see where we're teaming that up with other information where it might be useful. User agent, which is their browser type. This is absolutely useful, particularly for detecting bot activity. And what you'll find is often, fraudsters are using bots to commit the fraud. And often what they'll do is they won't update their browser settings. So they will be presenting an old browser version. And as you know today, if you go on something like Chrome, as soon as a Chrome update is available, it gets pushed out to your Chrome browser. So it comes out with a new version. So if we see a very old Chrome version as an example, that would be a really good indicator of fraudulent transactions. Category type, yes, absolutely. If people are selling, electronics, that's a typical target for transactions. So that'll be really useful information. Same with the price. Typically, you're not going to get fraudulent transactions on anything that costs like $5 or less. So unusual for that for that to be fraudulent transaction. And of course, the higher the value, the more likely it's going to be fraudulent transactions. Currency payment, possibly, compared to the country that we're transacting in. So we can, if it's a New Zealand transaction, but they're trying to, do a USD currency, that could be an indicator. And the merchant sometimes can be a good indicator as well, because who they're buying from, there's certain merchants that, could be targeted. So that could be useful information as well. So we have a question. Can you give an example how the detection works when only the mandatory fields are provided? Yeah, so when we only provide the mandatory fields, what you're relying on there is a lot of the historical Amazon knowledge, right? So what we'll look at is what we've seen with transactions before and say, okay, based on this, here's going to be, this is why we believe it's fraudulent, right? For each fraud prediction we make, we will tell you why we believe it is fraudulent. So out of the data that you provided to us, what feature that you provided was most predictive on it being fraudulent. So why we believe that this was fraudulent. So for example, maybe it's the high price or order price, maybe it was the category, maybe it was the the IP address, for example. So we'll be able to tell you for that fraudulent prediction. But to be honest, you don't want to just produce the mandatory fields. As a bare minimum, you should have other information, right? You should definitely have the product category. You're probably definitely going to have the order price as well. You should have the IP address that it comes from. You might not have the email address, but as a bare minimum, every transaction, you should be able to provide what they brought, how much they paid, what their user browser was, what their IP address was, and those mandatory fields, right? And that's going to give you a much better model. Looking at this data here, I got to be honest, this data is not good data when it comes to predicting a fraud model. And the reason why is because it doesn't include the shipping address. From my experience, the shipping address, comparing that to billing address, is a really, really good predictor of fraud. The second thing that it's missing is actually the makeup of the goods. So what are they actually buying? What's in the cart? Yes, I've got product category, which is a good, that's a good starter. But what would be better is the actual individual items they're buying, because that becomes a much better predictor of the fraudulent transaction, right? So whether they're targeting iPhones or Samsung phones. What we've found, interestingly, another really good one based on what I've seen in the past, is if it's transactional fraud, the size of the shipping package is a really good predictor, because fraudsters don't want to buy a 75-inch TV, even though that might, that looks like, that seems like a really good target, right? 75-inch TV, probably $2,500, that'd be easy to sell. Problem is, they have to ship that to whoever they on-sell it to, and that becomes difficult for them. So typically when it comes to small electronic goods, electronic goods, they want small goods that are easy to ship around the globe. So, product size and predicted shipping costs is actually a really good predictor of fraud as well. So you definitely want to take a look at that. Okay. So that's the data I provided. Like I say, this isn't great data because it was a sample data based on stuff where we had to de-anonymize it based on historical customer transactions. So I created a new model. You see this. I did this just before stream. This was about an hour ago. And I told it to go take that 100,000 records that I've got there and create a model. Oh, this one's come back with an error. So what's the error say here? So I've got two. Okay, so I've got from my event labels, I've got less than 50 that have been processed. So, okay, so it looks like my data needs a bit of tidy up, which is unfortunate. So let's take a look at another model I created previously. So here's the model I created previously. So this one was last year. And here is the result of this model. So this was using the exact same data, but it was from a year ago. So in this instance, there would have been a column that we now require that I didn't require a year ago. So that's why it worked. In this instance, I've been able to get a 0.97% accuracy. So what that means is 97% of the time, it would be able to predict whether a new transaction was fraudulent or not. So it was able to label it correctly 97% of the time. So even with that data, which is not good data, to be honest, I got really high accuracy here, 97% of the time. Once I've got that model, I can then put it into production. And to put it into production, we create what we call a detector. And a detector is essentially the API that we use to put it into production. The nice thing is we give you a test rig for this data. So for example, here I've got I can run a test, and you'll notice it's asking me for all of that information that I provided. So billing city, billing latitude, billing street, billing zip code, email address, etc., etc. So I'm going to provide some of this information, and then we'll get it to predict. I'm not going to provide it all for the transaction. I'm just going to provide some of it. So billing city, I'm going to say Auckland. For the email address, I'm going to say this is trev@moo.ai. Customer job, I'm going to say consultant. And then customer name, Trev. And then I'm going to give IP address of, let's do 123.45.67.89. Order price, I'm going to make this a decent size order. So let's make it $678. And currency, NZD. So there we go. I provided, currency, NZD. So I provided some information here, and then I'm going to run a test on that and get its prediction. So in this instance, it's come back, and two things it's provided as a result here. First of all, it's provided my insight score. So this is my fraudulent score. This is really high. It's 873. So that's a really high score. And it's also provided my business rules. So in this instance, it's saying this is a medium risk send for extended verification. So it's not saying in this instance you should automatically reject it. Based on my business rule, it's come back and said we should do extended verification on this user because it looks, it looks a bit suspicious. It looks like a high fraudulent activity. So in this instance, this one's come back as potentially fraudulent based on the information that I've done. Taking a look at those business rules, so here's the business rules here. This is where you get to create them, right? So I can come in and say, okay, I want to. Well, let's take a look at one that I've got here already. So this one is an auto deny rule. So in this instance, if it meets this criteria, I'm just going to be automatically denying it. And the only criteria I've got is If the sales transaction insight score, which is the fraudulent score, is above 950, automatically deny it. So that's a really high indicator that it's fraud for us. So because it's a likely fraud, our business rule just says, deny it. It looks too suspicious. We go back. I'm going to take a look at another one here. So let's take a look at that medium risk one. Let's take a look. Extended verification. So this is the one that sent me for extended verification. So let's take a look at the rules here. So in this instance, it was just looking at the insight score below 950 and above 800. So in this instance, it said, okay, all it's looked at, to be honest, all it's looked at here is whether the fraud score was between two values. I could have added extra intelligence here to say, does billing address match shipping address, as an example? Is it in electronics, as an example, right? So these rules I can build up on any of the fields that you provide. You can build up to make, to build business logic into these rules. Let's just take a look at some of the questions here. Based on what you've seen, how is this model trained on this? It's not quite sure what the question is there. Will clients have multiple address investments second hand? No, don't understand that one. Okay, yeah, not sure on those questions. Maybe just clarify the questions if I haven't had a chance to ask them there. Okay, so I mentioned extended verification. So what does extended verification look like? Let's say you've got a large transaction. It could be legitimate, but it might also be fraudulent, right? So you say, okay, I want to do an extended verification on this user. So you don't want to automatically deny the transaction to the user. What you might say is, okay, Mr. or Mrs. User, we just want to validate you are who you say you are. The way we want to do that is we're going to ask you to validate that you are the person doing the transaction that signed up to the original account. One way we could do that is using another AI service that we have called Recognition. But Amazon Recognition is the ability for us to look at images and tell you about those images. So for example, I've got a screenshot here this looks like a cityscape. You'll notice here under image properties, I've told you everything I know about this image. So this is out of the box. All you need to do is bring your image and we'll tell you everything we know about this image. So in this instance, we're telling you about the dominant colors in there, the brightness, the sharpness, and the contrast. If I look at this car photo, again, it's told me the key colors as part of this image. So what percentage is made up, the brightness, the sharpness, and the contrast. If I want to do labels, so I want to be able to see, I want to label everything in the photo. So in this instance here, I've got a labeled building. This is a person. This is a skateboard. This is a car. This is a shoe. This is a car. This is a car. So I've gone through and I've labeled everything we recognize within that image. Here's a different one. So in this one is looked at it and we've identified towers, architecture, buildings, cityscape, urban, metropolis, etc., etc. So in this instance, this is another AI service that you can just consume out of the box. You don't need to be able to, train your own image recognition application. It's an out-of-the-box one. We look at image moderation. So in this image moderation, I've loaded up an image. The result is no moderation labels detected. So we can view this content. And that's because we can see here that we just have a family on the beach. The second image, however, is a person in a bikini. In this instance, we might say, okay, this is a person in a bikini. It's suggestive. They're wearing swimwear. It's got revealing clothes. So in that instance, we can choose not to reveal the content, right? So again, this is just using the pre-built model. You just bring your data and it just works, right? So it's a SaaS offering out of the box. So how does this help with our fraud detection model? Well, one of the capabilities is facial comparison. So this is where we can compare two photos against each other and tell you whether it is suspicious or not. For example, here they're comparing this photo on the left-hand side with the photo on the right-hand side. So the first person we can see is 99.9% sure that that is the same person, whereas the other two people in the photo were sure it is not the same person. How do you use this for enhanced verification? When you get your user to sign up, you get them to use their official ID to sign up. So this is an expired passport of mine. I can see back here it expired back in 2018. And you can see it's got my photo there. This is when I didn't have my beard and I wasn't wearing my glasses, because you're not allowed to wear your glasses for your photo ID. If I get sent for enhanced verification, I can get the user on my website to turn on their webcam. I'll take a photo of them and I can compare it to their official ID. So I'm going to compare this to my LinkedIn photo. So there you go, my LinkedIn photo. So here I have a beard, I have glasses on, but it is still recognized that it is me with 99.7% accuracy. So the idea here is when we sit for our fraud use case, if we don't want to automatically reject the user, but they have a really high fraud score, so it's not low, so we can't automatically approve it, so they've got a high fraud score, but it might be legitimate, we can just ask the user to compare themselves to the photo that we have on file when they signed up to the website. So it's one way to do enhanced verification and not reject a legitimate transaction within our environment. And again, this is using recognition, which is one of the AI services we talked about. It's out of the box. You don't need to do any training for this. Yeah, all you do is when your users sign up, you get them to sign up with a photo ID, and then in the future, it allows you to validate any risky transactions. You could imagine if your bank, if someone's trying to send money from your bank account to another bank account across the globe, if your bank asks you to turn on your camera just to validate that it's you, that's probably not a bad thing, right? Built into Amazon Recognition, we do have liveliness detection, so we can tell you that it's not just a photo that they're holding up in front of the camera. We can actually tell you that they're alive as well. And again, that model is built out of the box, so it just makes it nice and easy to consume this. Let's have a look at the chat questions. Is it possible to run detection on a batch of data? It absolutely is. So let me show you that. Let's go back to fraud detector. So under fraud detector, on the left-hand side here, we have the ability to do a batch prediction. And with the batch prediction, it'll just run through all the transactions and then highlight to you which ones are actually what it does is it goes through the predictions and it gives you two extra columns. Column number 1 will have the fraud score, and column number 2 will have the output of your business rules. And then of course you can just sort on it to get the high risk ones for review. So one of the customers I'm working with here in New Zealand, a retail customer, what they're doing is they overnight, all the transactions get uploaded to S3 bucket. They get batch predicted, so they just run a batch prediction. At 9 o'clock in the morning, the person comes in the morning and they get a CSV file, and they just have to review the ones that have been highlighted as high risk, and then the other 200 transactions that have occurred overnight, they don't need to worry about. So it's just highlighting the important ones for them. So it makes it nice and easy to cut down the amount of work that you're doing. Next one, off topic. I suddenly expected to upload a selfie with ID for an order I'm trying to make to guarantee it's not fraud. Yeah, it's a good point, right? So this enhanced verification you're probably going to want to do for very sensitive transactions, maybe high value transactions. I can imagine if I'm sending $20,000 from my bank account to another bank account, I definitely want my bank to validate it's me, right? So in that instance, I wouldn't mind, because when I signed up for the bank, I would have had to provide an official ID anyway, a government ID, whether it be a passport or a driver's license or whatever it might be. So if there's $20,000 being transferred out of my account, personally, I wouldn't mind going through the extra step of just validating it is me, particularly if it's been flagged as a potential transaction. Cool. Okay. So that's fraud detector. Like I say, nice and easy to get up and running. It literally takes, as long as you've got the data, to be honest, getting the data and getting it in the right format and making sure you've got the appropriate columns, to be honest, will probably take you the longest part of this work. But if you've got historical transactions and you know which ones are fraudulent, you can literally get this model up and running in about 90 minutes. So you can have a working fraud model for your company in about 90 minutes, as long as you've got that data. Nice and easy to get up and running. And like I say, it's a quick way to get AI ML into your organization. It's a quick way to start saving money for your organization. So highly recommend you take a look at it if you haven't already. And certainly, if you have any questions and you're based in New Zealand, feel free to reach out to me. I look after the New Zealand market. If you're not based in New Zealand, but you want a bit of help, also, reach out to me. My Twitter's there. We do have a LinkedIn group. If you are a member, if you're not a member of the LinkedIn group, I do recommend you take a look at the LinkedIn group and sign up for it. Let me just show you that. So LinkedIn. And the group AWS Technical Community. So if you search for this, AWS New Zealand Technical Community, it's a group of people, like-minded people. It allows you to talk directly to the AWS team here in New Zealand. And have any questions or you need follow-up, we'll be able to help you out on that LinkedIn group. So jump on that. More than love you to be part of that community. And then finally, do remember, I am going to be running a series of sessions on Twitch under my Twitch account. This is how Twitch, that's Twitter. So the username is Huawei. There we go. You can see we're currently still live broadcasting. And there's me talking in the background. So yeah, jump on, follow me on that one. What I'll do is I'll be starting a session on machine learning. So starting from machine learning, if you haven't had any experience about it, but you want to get into machine learning, jump on here and we'll be able to learn together on machine learning. And I'll be able to point you to sort of really good resources on how to get up to speed on it. And I'll also show you how to use SageMaker. I'll show you how to get new models up and running. I'll show you how to get, generative AI. That's a really popular area at the moment. So get your own Chat GPT working, get your own, Mid-Journey or DaVinci working. So, we're going to do that as a series for the rest of the year under that personal account. Unfortunately, we can't do it on the official AWS one. They're all booked up on the time slots, but we can do it on that personal one. So if you're interested, do follow me over there. And we expect to start that at the end of this month. So be happy for the follow. Excellent. Thanks very much, everybody. It's been good speaking to you today. Let me just double check. Questions. Do we have a schedule for the upcoming machine learning sessions? So we'll be starting the machine learning sessions at the end of this month. I haven't settled on the time yet, but we'll come back to you on the time. If you've got any recommendations on the time, do let us know. We'll be keen to find out what time is best recommendations. I think middle of the day, people are at work, so maybe not so great for the middle of the day, especially if we're trying to learn together. So maybe early evenings will be where we look at timing it. But good to know. Excellent. All right, guys, really appreciate, and girls, I really appreciate you taking time, and we'll see you next time.